Okay, so let's continue with the 99 problems, right? But we are doing them in Haskell, and I think we were we left it at this one, like we've done it to drop every nth element from a list, and the next one would be this one, splitting a list into two parts, and we have the length of the first part, right? So, and we are like 1/5 maybe, or 1/6 even, done to the list of problems, so pretty lame. Like, it takes quite some time to do them, but you know. Okay, so yeah, we have to basically split a list into two lists, I guess. Let's see one example. So we have a single list, then a number, and then we get first part and the second part. Okay, so I guess it's gonna be called split. So the split function is gonna take in a list of A's, I guess. Here they used only string, but can be anything, I think. Then we get the number of elements for the first list, and we return two lists. Okay, now I could use take and drop, and I think that's what you are also supposed to use, maybe. So we have the list and the number of elements, and what we need to do is take an axis and drop an axis, right? Like, that's the thing that we need to do. Maybe they intended to make it such that we implement take from scratch, but I don't think that is very interesting. So let's just make it work, right? So this would be first case, and the second case would be, let's say, if we try to split more than we have, so that's a good edge case. Okay, like this. So we get the 3 elements, and then for this one it looks the same, so I think it's fine. Okay, the next one, extract a slice. Okay, so kind of a combination of what we did. So extract a slice, right? In this one I can see that we have a list, then we have two indices, the start, I guess, and is it the end? Yeah, it is the end. Okay, so the start and the end, and that's what we need to return. And the function is called slice. So it takes in a list, two numbers, and it returns another list. And they called them I and K. So I think the easiest way to do this one is to drop I elements, right? We drop A and B, and then we take K k minus I plus 1. Feel like that's how you do it. So first, like, I mean, you know what, let's also do JCI. Might be more intuitive what's gonna happen, right? So let me just print slice 2 and 6 just to have it here, but you know it's not gonna work yet. So replace this with commas. Perfect. So now we can just copy paste it, right? So if we show this, it's gonna be just the list, right? Then if we drop 2 elements, we get the list from here onwards. And then if we take 5 elements, which is, you know, 6 minus 2 plus 1, we get the slice. So slice is gonna be basically take k minus I plus 1, and I guess, you know, it's from left to right, so we first drop I elements, A. First we drop I elements, then we take this many, so we are gonna slice that thing, and yeah, it looks like it worked. Rotate a list and place it to the left. I mean, I guess what this is going to do is take the first element, put it at the end, and this one at the end, and so on. But I think it's easier to just take all of them all at once and then move them all at the end. So it's gonna be a combination of split, right? And then after we split, we just swap them around, I think. So yeah, if we take a look here, so we have this one, right? And oh yeah, a way to, I guess, load modules, if I remember correctly, is it I don't know, is it load, and then we can use main, so is it app/main? Okay, I guess it works. So we have this thing, right? And if we split 3, I think that's the example, split 3. Oh, it's the other way around. Split 3, we get these two, right? So we get basically left hand side, or I guess A and B, and then if we do B and we append A, we actually get the rotated one, right? And yeah, that's how it looks like. So yeah, I guess that's what we have to do. We have to split and then just combine them. So string line, let's print the title, and rotate is gonna take in a list, number, and returns the list. N, okay, N. So yeah, basically we can do it either with let or with where. Usually I like more where. Is split xn. what do you... Okay, I mean, we have some, I mean, yeah, those two. So it looks right. Remove the kth element from a list. Well, this one could also be interesting. So let's say we want to remove element at index 1, right? So I would say we need to take 1, right? And we need to drop 1 plus 1. And then combine these two together. So it's similar to split. But it's one more element on the right slice. Okay, yeah, I mean, you know, we can just do it. So it's gonna be remove at. So let's say we have a list, a number, I guess. Well, I mean, now this function has the, okay, let's keep it like the example. So basically remove at. I was thinking, you know, we can either use split or just, so it's gonna be k and axis. So as I said, we take k from axis and then we combine with drop k plus 1 from axis. So if we remove at 1, we should see the list without the b. Yeah. Ooh, interesting. Insert an element. Alpha. Sigma. Jesus. Okay, so insert an element. So it's gonna be insert at. So it's we get an a, int the list, and return the list. Right. So we get the element, the index, and the list. And what we have to do is, well, let's call it E for element, and let's do something like A. Well, first of all, let's split into A and B. So it's gonna be A, right, like this. We take the left hand side, right hand side, and in between those two we put the element. Set that alpha. So between A and B we should see the thing. We actually do see the thing, so that's good. Okay, this one is range. So in this one we want, like, we have the lower number, higher number, and we want to generate all the numbers in between them. including those two. You know, that's pretty easy to do. In Haskell it's like, whoa, 4, 9, right? But I guess the idea would be to implement this thing by hand. I don't know though if that's the point. I mean, it says beginner, so oh, but it's if the first argument is greater than the second one. I don't know if that works. Yeah, so okay. So beginner thing? Holy shit. So if the first argument is greater, then we should have it in decreasing order. No, I'm curious if they used like range or something. Oh no, they just did recursively. Okay. So let's say AB. And yeah, this one got me stuck for a second. Anyway, like I think we need a separate function, or maybe we can even do something like an if statement, right? And have two separate functions. Like, who cares? Like if A is greater than B, then we do dec, like decreasing order, and I guess we can pass in A and B, and else we can have something like increasing order A and B. And dec should be something like, okay, it gets in A and B, and I guess, I don't know, if A is equal, I don't remember if it's 2 equals, then it returns nothing, else it returns A combined with dec plus 1B or something. Okay, it's 2 equals. Okay, fine, fair enough. Let's do A prime so that we don't shadow it. So it's like, okay, minus 1. So it's like we have two numbers. If they're equal, then it's gonna be an empty list, and otherwise we return the first number and recursively go again, basically, and we decrement the first number. So I'd say that's pretty scuff. Let's see if it's gonna work. Range 4, 9 and range 9, 4. Okay, that didn't work. So I said that here A is greater than B. Okay, what? I mean, which one doesn't work? The first one? Okay, what? So if A is smaller, right? Oh, I have to think. Okay, so it seems like it almost worked. So let's say then, instead of equal, let's put greater. And here let's put less. Or is it the other way around? I think, yeah, it's the other way around. Okay, so now we also have the limits. Okay, fair enough. Let's forget about this one. Pretty ugly. Extract a given number, random number. Well, I mean, we don't really have numbers or like random stuff, so I feel like it's a bit useless. Like I would have to add the random here, so wait, system random? Huh. Oh, yeah, it is a package. Okay, do I add it like this? I don't know what this thing means, but I'm gonna do it the same. Let's do Kabaran. Okay, maybe without the last one. Whatever, it seems like now it's working, so it's fine. Anyway, so extract a given number. But is it like it's repeatable, or is it like only once? I don't know. Okay, so random select. Let's see. So this one takes in a list number and returns a list. Random select. Okay, so I feel like let's copy paste. I feel like we need to pass these things into the thing itself, so Okay, I mean, I have no idea what the example does, but yeah, I completely agree. Okay. Well, you know, it's actually something that we kind of need, almost. Because it's like we can take the indices of the array basically. So where roles be like this, and here let's say 0 length axis. Okay, so it's a lot more stuff. So this one, eight, and uniform, is it like 4 usually? For this one, let's say n prime or something. So we can use this one to get the indices of the elements. I don't think it matters if we repeat them though, so that's something. Okay, and I see that we can ignore this one. So, oops, let's say generator is gonna be this thing. Because it looks like it works, right? So this should give us a couple of ints. I mean, honestly, why not just do it like this? And now it just gives us ints. So then we can maybe do something like map, and then we are going to have a function here that we are going to apply on roles n, right? So this should be a function that takes in an index and returns an element. So this is the index, and this is how we take the element. Okay, yeah. So we can just use this. Just reuse those. So this should probably just work, I would say. I mean, it's random, but you know, up, like you'd have to pass in the seed to this one if you want to make it truly random, but whatever. So in this one we give it a range and we want numbers. So I guess we give it two numbers, like int. Okay, I get it. So we give it how many and the upper limit. Okay. So we give it k and n, right? So in this one I would say it's, but again maybe it's gonna repeat the numbers, so here it's different. So maybe here it didn't matter. Yeah, like selecting different number is a bit tricky. Let's see if this one took that into account. Honestly, no idea what happens here, but picked. Honestly, it doesn't look like they took into account repeating numbers, so. But for this one, like, but they did actually. Wait, where does that happen though? So random init, extract. Okay. Okay, fair enough. So maybe we can do something similar then. So more like let's try to make a auxiliary function here that is gonna basically take in a list and it returns a single element and the rest of the list, right? So the list is gonna be like something wise, for example, and we should probably do something like let index is gonna be uniform r 0 up to length of y's and whatever, like the seed, right? I don't remember how you use let. Oh, let. So we have let this thing, right, the index, Have an idea how to use this crap. What's unfold R? Oh, what the fuck? Wow, this shit is crazy. So it's the reverse of... Yeah, let's not think about it. So uniform R, what the fuck does it do? So it gets in a range. Oh yeah, okay, it returns A and G. So it returns I and something that we don't care about. Okay. So is... okay, it's an int, perfect. So what we want to do then is basically wise I and remove at. Finally we have to use our own function and we remove I. Okay, and if we want to do multiple roles, I guess we should probably maybe we can make use of unfold. So for example here, so unfold is a function from okay, makes sense. So I'd say here go, and here axis doesn't like that. So I think, oh my god, but that's Well, I thought that if you use fmap, it makes it from A to... Okay, do I need to use parentheses? Oh, looks like I have to use some kind of parentheses. And this might as well just be dot. I mean, obviously this doesn't really work that well, but whatever. Like this could be a maybe, and if the list, right, maybe it's gonna be easier to do. Right, so now we don't need the just here, so it's looking a bit better. Okay, and now I is actually the element, so it should be just roles. Okay, like actually unfold R, I haven't used this one before, so it's pretty neat function, I would say, because I was always finding cases like this. So this one is actually pretty funny. Let's see if it's still working. Now the elements should be always different, so okay, I mean, I'd like to have seed as an argument, but it is like an extra library, what the fuck? I mean, having to use a but how do I get to like the latest version? Here is like okay. Like, does it make sense to add this thing? I'm curious if you can do cabal add. No. So you literally just have to do it like this. I mean, you know, it's like fine, you know. So it's like 1.12. Strange. But maybe it's because of this. Okay, whatever. Oh, I need to fix this. Oh, index too large. It's crazy. Oh, I guess -1. I don't know. Maybe it's inclusive range, so yeah. Yeah, so maybe it, you know, was inclusive range. So okay, we have time already. We should. So the example from here is get current time. Well, we could use this thing to get UTC time, and then what we can we do with UTC time? it's time for Google. I'm looking for something like UTC time to int. Let's search for UTC time. Bro, like, how is it so time to what the fuck is it so hard to get this thing? Like, what? Like, I just need a number of seconds. What is this diff time? Man. Oh, picoseconds. Well, I mean, you know what? Like UTC. So wait. I guess this should be a map, fmap. So we get diff time, and for diff time, we could actually just say something like this. Wait, what? Oh, I wanted something else. 5. Perfect. So I mean integer, right? So whatever. Oh, really? From integer. Okay, fair enough, whatever. So now it uses time. So yeah, I don't know, maybe it's working now, I don't know. It looks like it's random. A bit random. So yeah, whatever. Let's ignore the random part. So let's go back to this one. So it's basically all we have to do is create a range from 1 to n and then run select k. And we also need the seed here. it. So okay, this, okay, weirdly enough it's like this, but auto select 6 9. So 649. Oh, yeah. Oh, also the seed. So the seed is time. What the fuck? Oh. No, it's because, yeah, it doesn't really work that well like this. Because I guess this just resets the seed every time, so ugh. So then maybe this should be G and A, like this, right? So here we don't care about it, and anything, and here is gonna be G and the Y's. And instead of doing this thing, we do it here, and uniform, this should be G prime, which we return here, right? Something like this. And here we do axis. Okay, and what's the error? G needs to be random gen G or whatever. Let's see again. Yeah, now it looks more random, I'd say. Okay, fair enough, whatever, now it works. That's what I wanted to see. Random permutation. I'm curious. So it's just gonna be that, right? I mean, how I'm gonna implement this one is similar to this thing. So we take in the seed, we take in the list, and we do the list. So seed and the list, right? So it's basically just gonna be rand select seed axis it's just gonna be that, right? Like we print if we take the length of axis and use it in random select, then we just take all of them, so it's gonna be wow, what I said int should probably be a. Okay, so I mean it's random permutations, looks like it is random. Oh, what the fuck? Combination of k distinct. So I guess we are done with the random, right? Okay, I mean this is like combinations or what? Let's try to do it. At least we are done with the random crap. Okay. So this is called extract. Looks like it takes in number and it wants a list of lists. Okay. So it needs k and the list. No, I guess this, fair enough. The k and the list. So damn. Yeah, this one is gonna be quite interesting, to be honest. Whoa, it looks really simple. Damn. Like, I vaguely remember how to do it, but I have no idea at this point. Like, the idea, if we try to take a look with GIMP, for example, is that, let's say we have a list, right, of elements A, B, C, D. So and it was something like we choose the first element, or we have the option to either choose it or not choose it, right? So it's gonna be either A or an empty list. Then when we go to B, we either have the option to choose B or not choose B. So we have this, and on the other case is the same thing. We either choose B or we don't choose B. Then we go to C, and again it splits. But this gives us all the permutations, I would say. But after that we can filter by length, so that's an option. So that's how I would implement it. But question is, how did they do it? I'm curious. Oh, I guess that's exactly how they did it. But they kind of kept track of k. So let me see. If k is less than 0 or equal, then it's an empty list. Okay. Otherwise, empty list is empty list. And then if we have head and tail, then we can either do with h. So with h is just gonna do what I said, is gonna add h to the rest of the list, and without h it just goes again. No, I mean, we can try to do it like this. So it's something like k is more or equal to 0, then we have an empty list, and otherwise, well, I guess otherwise we can still well, can we? Otherwise, fine. Yeah, I think it's easier to well, we can have something like this. Extract k, well, this should be like this, and then extract k and an empty list. That looks like it's gonna be an empty list. And then what if we extract k is something, and we have head, or I guess x and axis. That's how I would do that pattern match. So then we have the two cases where we take h and where we don't take h, right? So let's see if it's gonna work like this. Like if we also take into account k, maybe it's gonna work. So let's do a let. Why not? Let with h, or I guess with x is gonna be, let's map. We are gonna have something here, and then we do k minus 1 on axis, right? And we also want without x k axis. And then we combine both of them. So this should be list to be, I guess this should be like a pair that we get, or combination, and we want to add that. So might as well just use xcons, or like if you look from if you turn your head 90 degrees, like a face with a next mouth thing, yeah, whatever. Okay, so let's steal this one and then extract to, let's see. Oh, huh, so it actually did work. That's crazy. Yeah, I I mean, you know, it just freaking worked. Yeah. Okay, I mean, pretty cool problem. Okay, I mean this one, come on, what the fuck does this mean? Yeah, I think we will leave this one for the next time because I mean I have no idea what this wants. But yeah, so no, made some progress, went through I guess 10 problems or something. They were like annoying with random, so let's give it that. But the ones with lists are interesting, so at least yeah, we got some list problems. This one was obviously the hardest one so far. Probably, I mean, still beginner problems, but yeah, whatever. So yeah, we'll see next time how to do these kind of problems, let's say. So yeah, see you in the next one. Bye.